All right, guys, so on your desk, you have a green formula sheet. This is your formula sheet for the test and for the exam that you'll get to use, so don't lose it. So right now, write your first and last name in the upper corner so we know if it gets left behind, I know whose it is, who it belongs to. But on that formula sheet, there are 6 of them, and we have done 3 so far. So simple interest, compound interest, APY, those are the 3 easiest formulas, okay? And then there's some crazy ones on there, right? So you understand why I don't make you memorize these, because they get a little weird. One thing I'm going to want you to do here in a little bit is we're going to change the name of compound interest. We're going to write a different name on that one here in just a little bit, just to try to help you keep all of these straight. Because honestly, is it hard to plug numbers into a formula? No, it's really not. The hardest part of all of this is when it comes time for your test, it's not like, here's the simple interest problems, then here's the compound, and then here's the APY. Like, they're all intermixed. You have to decide which formula of these 6 goes with that problem. That's what makes them hard. Okay, so we're going to continuously work on how to tell which formula goes with what. The person who failed the test yesterday, the biggest issue is they used the wrong formulas. Okay, and I know you only had the 3, but what happened is it was a simple interest formula, right? The problem talked about simple interest, and then later on it's in like part A, B, or C, or whatever, it was like, what's the balance? So that student then went, oh, balance, I used the B equals formula. No. Or if it was compounds, which gives you the balance, then my next part of the question was, how much interest did they earn? And then they went, oh, interest, I go to the I equals formula. No, it doesn't work that way. Okay, so that's like the biggest thing is people mess up those formulas. All right, so for today, we are looking at the future value of investments. So future value, meaning in the future, 5 years from now, 10 years, 30 years from now, how much money will I have? Okay, that's what we're looking at. All right, so going back to what we've already done, that compound interest formula. Right, we've done this. Suppose you open an account that pays interest. You make no further contributions. You leave your money alone and let it compound interest work its magic. The balance your account grows to at some point in the future is called the future value of a single deposit investment. So on your green paper, where the box that says compound interest, I want you to rewrite either above it or below it, future value of a single deposit investment. So what's bold and underlined, I want you to write that on there. So probably like right above. So on your paper, you have compound interest, right? This top one, compound, this formula. So right above it in that box, I want you to write, it says future value of a single deposit investment. Because that's technically what that formula is. Right? That formula, when we've used that, you've looked at, okay, I put $1,000 in my account. How much is in there 10 years from now? Right? So you looked for what's the future value of a single deposit. One time you put $1,000 in. Right? And never put any more in it ever again. Okay? Now, does anyone put money in a savings account? Do you have like maybe your check kind of split apart? Does anybody do that where like so much of each check goes into a different account? Yeah? Oh yeah, you can go. Okay. I know like this is one thing that I do, like my check when I get paid, I get paid twice a month, not every 2 weeks. So every time I get paid, $100 of my paycheck goes into a separate savings account automatically. It's like I never even saw that money. Right? That's just that way I kind of get like a little stockpile of cash going for the rainy day fund, right? In case something happens, there's always some money sitting to the side. So for me, this formula doesn't work. Because what is this formula? How many times am I putting money in here? Once. Right? This formula is a future value of a single deposit. It means I put one time I put money in and that's it. But that's not what I do. Every single time I get paid, I put money into it. So we need a different type of formula. All right, so I'm going to bypass this review part because I know you guys are good at this stuff. What? What? Mm-hmm. Yes, my bank does. Well, no, here. Kind of does it.
They pull it out for you?
Mm-hmm. Yeah, I set up with payroll here and how that gets up because we have direct deposit. So I have to tell them what bank to put it in. So mine actually gets split 3 ways. I have $1,000 of my check goes into a separate checking that pays my mortgage. $100 goes into a savings for just backup money just in case, and then the rest goes into my everyday checking that I use all the time. Yep, so my payroll automatically splits my check into 3 different spots every week or every time. Yes, you need to have the account set up ahead of time. Yep, but no, it's a great idea. That way I get used to it. To me, I feel like I don't make that much money because $1,000 of my check automatically goes to pay my mortgage. Do you know what I mean? But then I don't feel like I have a mortgage payment. You know what I mean? Because it automatically comes out every month as well. Right? It's the illusion. But I get used to living without that. You know what I mean? All right. So the new part for today then again is we're looking at periodic investments. So periodically I'm putting the same amount in. Like me, it's every time I get paid. So twice a month. What's that called? Semi-monthly. I put $100 in that savings account. Okay. Now I could give the example of my twice a month I put $1,000 in my checking that pays my mortgage, but that comes out every month, so it doesn't continuously add up. My savings account does. All right, so it's in at regular intervals. So like every year you put that money in, or every month, or every week, or every day. I don't know why people would do that, but you know what I mean. So that's what we're looking at. So there's your formula. Everyone make sure you have calculators on your desk today, the one that you normally use, so we can make sure we know how to plug all this stuff in. It's not hard to plug numbers into a formula, but sometimes these crazy fractions and parentheses and whatnot get a little crazy. If you use the graphing calculators, to me it's so much easier because you can see it and it should look just like this. When you use the scientific ones, if you don't have parentheses in the right spots, it makes it a little hard. Okay?
So it's all the same. It's all the same stuff. It's just
yes. Yeah. So guys, that's great. Joanne noticed. He's like looking at the formula. He's like, wait a minute, that's all the same letters that we've been using. And he's right, they are. That's all right. Variables, right? Your brain was going to variables. Yeah, they're the same ones we've been using. They're just in different spots. Now, if you are using a scientific calculator, before we even get going in this, let me kind of try to help you out a little bit to begin with, okay? If you're a scientific calculator person, you need extra parentheses. So if you know you're going to use a scientific calculator, you're going to want to jot this down on your green formula sheet so you don't forget, okay? So if you're using if you're using graphing, then just don't even listen to me right now, okay? Scientific people, though, you're going to need an extra set of parentheses on both sides. So if you miss one parenthesis, you're wrong, okay? So you have to make sure you get them all in there. Also, you would use the division sign, not a fraction, if you're doing this, because scientific ones get all freaked out when you do stuff like that. Yeah, I think I should let you use the fraction there. And then at the bottom, again, you're going to need parentheses around that. I think I got all your parentheses. Scientific people, we'll try it in a little bit. We'll make sure I didn't miss any. But Joanne's right. If you look at all those variables, it's all the same stuff we've always done. Okay. All right. So Rich and Laura are both 45 years old. They open an account at the FST Savings Bank with the hope that it will gain enough interest by their retirement at the age of 65. They deposit $5,000 each year into an account that pays 4.5% interest compounded annually. What is the account balance when Rich and Laura retire? All right, so first thing, and this is so important, you guys, is the formula. Please write down, I know they get kind of big and ugly, but please every single time write down your formula with your numbers in it before you type it in the calculator. Because what's going to happen is you're going to type something wrong in the calculator on your test. All I'm going to see is an answer, and I'm going to be like, I don't know if they just typed it in wrong, if they used the wrong formula. I'm not going to know what you did wrong. Okay, so let's try to get in the habit of always writing everything down. So we go through this one. So B equals, so our ending balance at the end of all of this. All right, my principal amount, how much are they starting with? How much are they putting in every time? 5,000. So the principal in this case is what they're actually putting in every single time. then I have two parentheses. 1 plus my rate. Good, 0.045. Divided by n. How many times is this compounded? Once, because it says annually, so it's only once a year. And then it's 1 times, what's the time? 20 years, good. It said they're 45 now and they're going to do this until they're 65. That's 20 years from now. And we have a minus 1, close parenthesis. All of that over, that's r over n, right? Yeah. Okay, so my rate, 0.045 over n, which was 1. All right, so please write it down first so I know that you're using the right formula. I can see what numbers you're typing in. And then let's go to your calculator and try to type this in. Now, graphing calculator people, when you're typing this in, you want to start with a fraction. Okay? So you're going to hit green button, y equals, enter. Right? You remember all this? So hit the green button, the y equals button, and then enter. You're going to start with your fraction, and then in the top, let's type all of that in. And again, are you going to put another fraction in the top of that? Uh-huh. You're going to have fractions within fractions. You're going to have this huge, lovely, decked out thing. All right, so let's go ahead and try typing all this in. And again, if you lose one parenthesis, it's wrong. All right. If you did it right, we should have gotten $156,857.11. That's what it should be. So take a minute, see what you get, and then if you're not getting that, let me come check and see if I can figure it out for you. All right, but do we see the difference with this type of formula versus the last one when we only put money in once, right? It was just a little bit higher by the end. This, $5,000 every year for 20 years, he's up to $156,000, right? That's kind of nice. So the number 2, how much interest will Rich and Laura earn over the 20-year time period? No. Did we earn simple interest? Yes or no? Did we earn simple interest? No. No, I'm glad you asked that because that's what people are going to do. They're like, oh, interest, simple interest. No, don't ever do that. Unless the problem says simple interest, somewhere in there, you don't touch that formula. Yes. All right, guys, take a look. Abby is correct. They are putting $5,000 every year into the account. How many years are they doing that? 20 years. So we're going to have to go 5,000 times 20. So we had to figure out how much did they personally actually put into their account. What? So that's a lot of money, right? So they personally put 100,000 in. And we, doing the formula, found they're going to actually have $156,857.11. So how much of that then is interest? Yeah, obviously, this is a real easy one, the way it's set up. But what you're doing is you're subtracting that then. Yeah, so $56,857.11. I don't know, what do you guys think? $56,000 in interest? How's that? That's pretty decent, yeah, I'd say.
That's 20 years. Okay. It looks big, but it's not.
Yeah, but that's $56,000 for free. That's just, bonus money, you know?
Grandchildren.
Right, you could figure out how much interest per year, yeah. I'd say that's pretty good. I'd be happy with that. All right, number 3. Linda and Rob open an online savings account that has a 3.6% annual interest rate, compounded monthly. If they deposit $1,200 every month, how much will be in the account after 10 years? So again, as we're going through all these different formulas, we need to know how to recognize them. This one, I'm looking at the questions asking how much will be in the account in the future, right? So that's what your brain should automatically like, oh, it's one of my future value equations, right? So you notice you also have present value that we're going to talk about tomorrow. But future, so you're like, okay, they want to know how much is going to be in there in the future. So there's my future value. Is it single deposit or periodic deposit? They're putting money in, what's it say? How often are they putting money in? Every month. They're not just putting it in once and walking away. Every month they're putting it in. So it's going to be future of periodic. So you have to be able to like read through the problem to figure that out. All right, so we have B equals, they're putting 1,200 in, 2 sets of parentheses, not 1. 1 plus my rate, so 0.036 over n, compounded monthly, so it'd be 12. To the 12 times how many years? 10. Minus 1, close parenthesis. And then again, my rate, 0.036 over 12. Yeah. The 1,200 I'm putting here?
Yeah.
No, we're assuming we're figuring this out from the very first time they put it in. So from the very first month. Because it's always going, the way these...
First one's by year, the second one's by month. So it doesn't change. It doesn't
No, it does not. Guys, one thing I want to make sure, and I think Abby's starting to kind of pick up on this, every time that we do this, these problems, however it's compounded is also how often I'm putting money in. It's the same, and it will always be the same. That way these formulas actually work that way. Does that answer that question? They're always going to be the same. All right, so again, grab the calculator. Graphing calculator people, you got to start with the fraction. Scientific people, make sure you get those extra parentheses where you need them. We'll find out in a minute. All right, so you should get a balance of $173,022.87. Please make sure that you're rounding correctly. On your projects that I graded, I can't tell you how many of you got them wrong because you didn't round to the right cent. And if you didn't round to the right cent, what happened to every calculation thereafter? It was wrong. Yeah, some of you found that out, right? Yeah, yeah, Nathan's like, yep, he was one of them. All right, anybody not able to get your calculator, tell them that? Did you get to work? We're getting there. Haley, you good back there, hon? She's working on it, okay. All right, number 4, how much interest will Linda and Rob earn over the 10-year time? Very nice. So guys, take a look. He's right. They're putting $1,200 in how often? Every month. So we have to multiply that by 12. So doing 1,200 times 12 tells me how much money they put in every year. But we're doing this for how many years? For 10. So then I have to multiply by 10. So they put 1,200 every month. So 1,200 times 12, there's 12 months in a year, for 10 years. All right, so 1,200 times 12 times 10. So they put in $144,000. That works. Same, yeah, same thing. All right, and then the question though is how much interest will they earn? Well, we need to take this number and then subtract the 144,000 they put in, 173,022.87 minus 144,000. So $29,022.87. That is the interest that they earned. But do we see how we have to take how much they're putting in per month times by 12 to get how much they've put in a year, and then they did that for 10 years before we can subtract that off. That first problem was they put it in yearly, so we didn't have to multiply it as much. Questions so far? Are we doing okay? Yeah? All right, number 5. Robbie opens an account at a local bank by depositing $100. The account pays 2.4% interest compounded weekly. He deposits $100 every week for 3 years. How much is in the account after 3 years? So again, getting you thinking once I give you all these formulas. I'm looking at this going, okay, how much is in the account after 3 years? So in the future, how much money is going to be in there? So your brain's like, okay, it's a future value problem. And then he's putting money in how often? Just one time and done? Every week. That's a periodic, not a single deposit, right? He's periodically putting money in. All right, so B equals, let's go ahead and go again. So 100, 2 parentheses, 1 plus the rate, so it'd be 0.024 divided by, he's compounding weekly. What, Brian? How many weeks are in a year? Brian? Week, thank you. Oh, he told me 56 the other day. He was adamant it was 56. So then 52 times, we're doing 3 years, so times 3 minus 1. Again, if you're a scientific calculator person, you've got to multiply that together first. All right, and then my rate again, 0.024 divided by 52. Yeah, scientific people, you got more parentheses to put in. So 100, 2 parentheses, 1 plus fraction, 0.024 over 52, exponent 52 times 3 minus 1. On the bottom, another fraction. All right, so we should end up with a balance $16,171.46. Whoa, negative. Did you put a -1 or a -1 on your formula? All right, guys, part B. What is the approximate balance after 2 years? What's the only thing that changes? Say that again? Yeah, the only number that's changing then is this number. So the only thing you need to change is turn that 3 into a 2. Now, if you're calculator savvy, just go back up into it and change it. So like on the scientific one or on the graphing ones, if you just arrow up so it highlights your big huge equation, hit enter, it brings it back up where you can edit it. So you can just go back through and just change the one number, the 3 to a 2. If you're more comfortable and would like to retype everything, by all means. I'm just lazy, so I don't want to. So in this case, the balance you should get is $10,651.12. Double check, guys. Are we able to get that? If you're sitting here aimlessly writing down stuff and not trying this on your own, you're in for a world of hurt when it comes time to do this on your own. Right, Joanne?
Well, it's a calculator, you're not being a calculator.
You know, the calculators only actually do what you tell them to.
You told them to do something, you got 0.
Yeah, I don't know. We were missing something in that. I don't know. Couldn't tell you. All right. Are we okay? Yes. All right, last part. Number 6. Suppose $600 is deposited into an account every quarter. The account earns 5% interest compounded quarterly. What is the future value of the account after 5 years? Now, does every problem actually say future value in it? No, they don't. Not like simple interest, APY, those are real easy because those words are actually in the problem. This one a lot of times doesn't. This example happens to, but it usually does not. All right, so again, we're just going to type in our formula. So B equals, my principal is 600. 1 plus my rate is 5%, so 0.05. If it's compounded quarterly, what is that? That is a 4. Good. And we're doing this for 5 years. All right. So once you get that giant formula, let's type it in. See what we get. It's a little nerve-wracking until you get comfortable with all your parentheses.
Now, wait, hold on.
Okay, I'll hold off. How long do I have to hold off, Joanne? You got it? Nervous? $13,537.79. Yeah? Did you get it? Oh, that's not separate. All right. Part B. What is the approximate balance after 3 years? What's the only thing that needs changed? Yep, all of that, this 5 would just turn to a 3. So again, depending how calculator savvy you are, you could go back up and just change one number. So in this case, it would be $7,716.22. Hold on. Part C. How much interest?
Which one?
I'm adding it. How much interest after 3 years? I'm adding it. How much interest did they earn after 3 years? So if I want to know the interest, what do you have to do? You have to do 600 times 4, because they're quarterly. And how many years? 3. Right, you have to figure out how much they put in. So 600 times 4 times 3. So if they put in $7,200, right, they put $600 at 4 times a year for 3 years. So they've actually put in $7,200. And then we're doing this after the 3 years. So then you would take their final balance after 3 years and subtract off how much they put in. You would. All right, kind of, let's go back to Abby's question, though. It's a valid question. She's like, wait a minute, what if on a test I miss this, therefore I miss this? Yes. Now, guys, please pay attention, because that's a valid question. She's asking about if I miss this, then this is going to be wrong no matter what, right? Because if this is wrong, so can you still get partial credit if you do your work right, but you just use the wrong number because of that one being wrong? Yeah. So like, this is usually like probably a 2 to 3 point question, each of these. So if I can see what you did, you showed me your formula. Let's say you did all of this formula right. That looks beautiful, but your answer's wrong. I'm like, okay, obviously it was a calculator issue. So I'd probably take off 1 point because you did something wrong in the calculator, but you knew what you were doing. And then I would probably take maybe 1 point off of this one. The answer is wrong, but you showed me that you subtracted like you should have done it right, but you just had the wrong number to work with. Okay, as opposed to like -6 for the whole thing. So yeah, so please write your formulas down, show me what you're doing. So many of you love to just write the final answer and don't give me anything. If that's wrong, minus the total number of points, because I don't know what you did.